Ma'am, you are not audible. Hello, ma'am, you're not audible. Kindly check your mic. No, no, ma'am, not properly. No, ma'am, sorry. Ma'am, if you have any other laptop or you have hands-free, so please use it. Alexa, we are on live now. You can start. Maybe.
Yes, sir. Sir, we are going to start it.
Yes,
Am I audible right now?
yes, now perfectly audible.
Okay, sir. Welcome to all in the international workshop on technological advancement in renewable energy, current scenario, future perspective, and challenges. Today is the second technical session, and we are having the chairman of Professor Rajendra Shukla Sarji from the Head Department of Biotechnology Engineering, Bundelkhand. This session is co-chaired by Dr. Ritvibrata Malik sir, Associate Professor, Department of Environmental Science, MT School of Life Sciences, AUMP. And I'm Dr. Nidhi Shukla. I'm going to do this session. Our first invited lecturer is Professor Abhay Kumar Pandey sir. Sir, firstly, I'm going to invite our chairman sir to address this session. Rajendra Shukla sir, can you please
thank you,
address
ma'am.
the
Thank
session?
you. Yeah, thank you, ma'am.
Sir, can we start the session now?
Yes, ma'am. We can start without wasting
Okay.
any time. We can start the session.
Oh, okay, sir. Okay, sir.
Okay.
So now I want to invite Dr. Abhay Kumar Pandey, sir. And firstly, I want to just describe introduce him with his brief CV. Dr. Abhay Kumar Pandey, sir, is a professor in the Department of Biochemistry, University of Allahabad, India. And he is having 25 years of research and teaching experience. Earlier, he has served in Pune University and in the Institute of Biomedical Sciences, Dehradun. Professor Pandey has many awards and honors to his credit. He is fellow of SPR India and member of many academic bodies, including the National Academy of Sciences and Society of Biological Chemists India, India Science Congress Association, and Italo-Latin American Society of Ethnomedicine. Sir is having a lot of research activities. He is focused around oxidative stress and free radical biology, toxicology, antimicrobials, and cancer biology. 6 students have been awarded doctorate degree under the supervision of professor, and currently 8 students are working as a PhD student. In addition, postdoctoral students are also working in his laboratory. He has more than 90 publications to his credit, including many research articles in the International Journal of Repute and chapters in the books published by the Springer elsewhere, CRC Press, and other publications. Based on the Google Scholar citation, Professor Pandey has more than 4,000 citations, and one of his review article, Chemistry and Biological Activities of Flavonoid, which is an overview, has been cited more than 2,000 times. Professor Pandey is editorial board member and reviewer of many international journals. He is also executive editor of the journal Vegetos Springer. He has delivered many invited lectures and chaired scientific sessions in the national and international conferences, and as a resource person to academic staff colleges to various universities as well. He is also associated with the Science Communication Program of the National Academy of Sciences. Dr. Abhay Kumar Pandey, sir, I'm going to invite you, sir, for the invited lecture. Uh, Sir,
Thank you.
over to
Thank
you.
you. Am I audible?
Yes, sir, you are clearly audible, sir.
Okay. So first of all, I must apologize for the delay, almost 15-20 minutes
No
have
problem,
gone
sir.
on my part. So I'm sorry for that. So
No
I
problem,
would like,
sir. We
now
were eagerly waiting for you, for
yes,
your lecture as.
yes. Just a minute. I must show my presentation first.
Yes, sir.
It is. जा रहा है. Share.
Sir, your presentation is uploaded right now and it is visible to the screen.
But
You can
I
do the
think
full
first,
screen. Yes, sir.
I am looking forward to, yes. So this is now full screen. It is visible.
Yes. No, sir, it's not now.
It is not visible.
Sir, you can click F5. I think it will be full screen.
Okay. F5.
Yes, sir.
I have clicked F5, but I don't see any other response.
Sir, in your presentation slide, there is a symbol. If you can click bottom of the symbol in the last where you can see 83%, it will be full screen, I think so. I don't know why.
Where it is.
Here you can see in the bottom 83%.
At my screen, it is not visible 83%. Only one row is there. There is written mute, stop video, security.
Mm.
Or should I go for more?
Sir, you can continue, no problem.
So it is visible.
Yes, it is visible, sir.
And
You can
it
continue,
is
sir.
moving. I mean, slides are moving. If I'm going
Yes,
in
sir.
this way.
Yes, sir.
Okay, no problem. So, first of all, I must thank you all for giving me opportunity to interact with the international participants in international workshop conducted by MT University Gwalior. I've gone through the brochure and most of your presentation, I think they are related with the natural energy and their utilization, etc., etc. But here, when my presentation is concerned, my topic is slightly little bit different from major issue highlighted in your workshop. Here, in my presentation, I would like to give emphasis on natural products, especially from if we sustain our environment, we can get natural product, and those natural product can provide us curative aspect related with certain diseases. And in this curative aspect, we look forward to. So you will find that redox homeostasis is very common. I think most of audience, they are belonging to the similar stream. There is biology, chemistry, maybe interdisciplinary. So redox is very common word. So I have taken the topic redox homeostasis and its regulation by natural product. I wanted to test the sustainability of the environment because our redox, when we are talking about the redox imbalance in our system, obviously it is the result of the environmental changes we are facing in day-to-day life. So this is my topic. Hope you can understand and you can follow my lecture. This is the first slide. What is homeostasis? We know that it is the process by which a stable internal environment is maintained despite changes in external environment. So obviously, if we are moving, maybe in summer period, we are facing scorching heat from sun. In winter, we are facing chill. And accordingly, our body, or you can say our organ systems respond differently to different environmental challenges. So we need to maintain homeostasis. We know there is one term in especially thermodynamics when we talk about entropy. Obviously, if we are continuously performing one task to other and other, we'll find that entropy is increasing, means a lot of energy input is going in the environment. But it is you can say, essential feature of our cellular activity, you can say intracellular environment, that we try to minimize the entropy to minimum so that everything is organized with its DNA, RNA, or protein structures. So whole system is under homeostasis. Now, if we talk about the important variables, we find very commonly some pathological indicators I have written on the left side in the red. You will see blood sugar, fluid balance, body temperature, oxygen levels, blood pressure, pH, and there are many more, you can say, variables. Now, when we are talking about certain variables, we know that these variables must stay within certain range. Obviously, if there is hyperglycemia, we fall prey to diabetic complications. Similarly, if there is fluid balance, there is again edema or other complications. If body temperature rises, fever is there. Hypoxia by oxygen deficit, etc., etc. So the changes in the external environment can cause these variables to change. And we know, obviously, everyone on task is facing stress. And we have come across different dimensions that stress affects our organ system's activity in different ways, maybe at hormonal level, maybe at normal physiological level, or at other levels. So these variables should be maintained for proper upkeep of our physiological functions.
Sir, sorry to interrupt, sir.
Yes.
Slides are not moving now. So kindly,
Which slide is there with you?
it is showing this first one.
Only first one.
Yes, sir.
Oh my God. Oh. What about now? Is it visible? Second slide.
No, sir.
At my screen, it is moving. Sometimes these technical glitches are always there.
Hello, sir. Hello,
Yes.
sir.
Now, is it visible?
No, sir, it's not visible. Just click on share screen button and then select your presentation only.
Yeah. Please share screen button.
Yes, I had shared that part. I'm coming
Sir,
again.
it's not shared right now. You just click again on share screen button.
Okay. I'm trying
So
again.
click on share screen button.
Sir, go to Zoom screen, sir.
फिर से जाए क्या? हम्म? They go for again.
So first open Zoom.
Again,
I think you have minimized the Zoom screen. You need to open that Zoom screen and then
okay.
go to share screen.
Right here, launch meeting. इसमें तो हो गई।
फिर से मिलना चाहिए। यहाँ पे भी एक शेयर आता है ना,
शेयरिंग का भी आ रहा था ना
इधर भी है।
इसी पे,
नहीं सर,
ये इस पे भी नहीं है, इस पे नहीं।
नहीं सर, यहाँ पे क्लिक करिए।
ये है ना,
So can you move your slide? We
yes,
can
I'm
see your,
right.
yes.
Right now
Moving
it is visible.
Yes, sir. Moving. It's moving now.
Yeah.
It's moving, but it is part. This is
No.
not covering the complete screen.
Yes, it's fine, sir. You can continue with this way, sir.
Okay.
Sir, we
it
can
is
see. We
visible
can
to-
see easily. You can.
Okay then, no problem. So I was talking about important variables. Now this slide is visible to you. Important slides, variables within the body. Is it
Yes.
visible?
Visible, sir.
Good
Visible.
point.
Visible.
Yeah, it is
So-
visible. It is visible.
Okay.
Please continue.
So we have talked about the constancy of internal environment at different pathological levels, right? So in this slide, can you see dynamic equilibrium slides, right? It is visible. So I must continue. So in this dynamic equilibrium, you will see there is nothing but homeostasis. You can call it a dynamic equilibrium. There is always fluctuation up to certain degrees. So you will find blood sugar range, we have almost 70 to 110 milligram per 100 deciliter, or temperature 37 degree. You can find fluctuation in the body temperature, maybe systolic diastolic pressures, maybe 510 millimeter of mercury. They do not create any problem. Similarly, blood pH should be always maintained at 7.4. Higher blood pH leads to, you can say, alkalosis, and lower blood pH leads to acidosis. So these these variables always fluctuate, but our body system always tries to keep it well within acceptable limit until unless some pathological conditions are there. So here comes the redox reaction. So redox is a type of chemical reaction in which oxidation state of atoms are changed. Everyone has gone through the chemistry process. And when we talk about the redox reaction, you will find loss of electron, gain of electron, or loss of hydrogen, gain of hydrogen, or at oxygen level. So when we refer to the redox state in terms of living system, we look forward to reduced glutathione, oxidized glutathione. Homeostasis should always be there. Similarly, NAD plus or NADH concentration that should be equilibrated, or there are systems in which we can find NADP plus and NADPH in biological system. So if these are basically indicators of the redox state of living system, they must always be kept at homeostatic level. Now, when there is redox imbalance, we just feel oxidative stress. So what is oxidative stress? It is nothing but it is imbalance between the systemic manifestation of reactive oxygen species, means free radicals which are generated in our system, and our body system's ability to detoxify these free radicals. So if there is imbalance between production and detoxification process, we fall prey to oxidative stress. Now, when we talk about free radicals, we know they are the molecules or ions containing one or more unpaired electrons, and generally you will find they are highly reactive, and at the same time they are highly unstable. So if we talk about their properties, we know that they are highly reactive, they have very short life, short half-life, and again, if you see, they generate new radical by chain reaction. If we talk about atomic explosion, you will also find there is continuous chain reaction in the same way when living system, free radicals are generated until unless they are quenched, you will find continued production of chain reaction. And when free radicals are produced, they are also referred to as reactive oxygen species. If they are produced in the system, they can just target our biomolecules. They could be any, biomolecule, maybe protein, fat, carbohydrate, lipid, anything. So the reactive oxygen species or reactive nitrogen species, which are produced in the system, they should be quenched and they should be minimized at the base level. In these slides, simply I'm not going in detail, but this is showing the ROS production in living systems. And there are basically 4 different types of system. First is the 4 electron reduction reaction leading to oxygen and H2O production. So in this process, when oxygen is reduced, we can find superoxide radical production, we can find production of H2O2 or hydroxyl radical. Second is reactions involving H2O2, we can find if superoxide radical undergoes dismutation process, we find production of H2O2, then homolytic scission of the H2O2 produces 2 hydroxyl ions, and similarly, through Haber-Bosch reaction, we can also produce hydroxyl radicals. In the next, if we are talking about Fenton reaction, our body is richly supplied with, we know, transition elements, especially Fe2, Fe3 are always there in our living system. So in presence of iron, we find H2O2, that is hydrogen peroxide, is broken down to hydroxyl radicals. And again, the final fate of hydroxyl radical could be in the form of maybe H2O or other products, but till hydroxyl radical is retained, it is nothing but a deadly free radical. Similarly, we can also find carbon-centered free radical production may be peroxyl radical, certain organic peroxide or alkoxide, if we talk about. So these are diverse type of radicals produced. And this simply structure of some radicals are there, hydroxyl ion and hydroxyl radical. So I'm not discussing this aspect now. What is the free radicals life? If we find our system generates number of reactive oxygen species, we can have superoxide, we can have hydrogen peroxide, we can have hydroxyl radical, singlet oxygen, hydroxy peroxy radical, HO, or lipid peroxide radicals, RO, nitric oxide radical, peroxynitrate, so many radicals are produced. But if you look at the red colored radical, that is hydroxyl radical. It has half-life of only nanosecond. While other radicals, mostly they are having the half-life of seconds, milliseconds, or microseconds. Now, see the beauty of the nature. If we talk about Darwinian theory of evolution, there is always arrival of fittest, then survival of fittest. So, if we consider the generation of this free radical in the light of Darwinian principles, we find hydroxyl radical has been given only nanosecond time because nature perceived its deadly nature. Had it been given a microsecond or millisecond, it would have devastated our living machinery or living cell itself. That is why nature has just given it a nanosecond half-life. So whatever the you can say chemical attributes are needed, that is performed well within nanoseconds. In this slide, you will see different transition metals are responsible for promoting ROS production. So if we talk about maybe iron, copper, nickel, chromium, in our system, they are present, and wherever they are present, at one step or other, we can find the production of H2O2, HOCl, lipid peroxides, and so on. Now, sources of ROS, if we talk about. So we can have two different type of sources. One is exogenous, other is endogenous. Exogenous means formation of ROS, reactive oxygen species, can be stimulated by variety of external agents. They include pollutants, tobacco, drugs, radiation, heavy metal, smoke, or xenobiotics. So if we correlate with our environment, in fact, almost 100 years back, our environment was very clean. We did not have pollutants, or you can say we had radiation safety because of the ozone layer, proper ozone layer formation was there. Now we find pollution load is increasing, heavy metal load is increasing in the environment. We are taking much more drugs and other xenobiotic compounds. Smoke is increasing in the atmosphere. So all these are responsible for production of reactive oxygen species in our system. In this slide, we can see the endogenous sources of reactive oxygen species. Now, you see, everyone knows that mitochondria is responsible for production of ATP. So generally, 0.1 to 2% of electrons passing through electron transport chain is prematurely and incompletely reduced to give superoxide radical. It is a natural process. Means 0.1 to 2, you can say 98% of the electron pass through our electron transport chain very clearly. But 0.1 to 2%, they are prematurely aborted. They cannot pass through our electron transport system. And in this process, they produce superoxide radical, obviously. So this is a free radical. Similarly, electron transfer reactions catalyzed by mitochondrial P450 system, especially in steroidogenic tissue. We know our testes and ovary in human beings, in males testes and females ovary, they are referred to as steroidogenic tissues. And you will find during the P450 system in mitochondria, there is also the leakage of oxygen that produces peroxide radicals. Now, if we talk about the production of reactive oxygen species, especially in testes and ovary, there is a possibility of, you can say, fetal damage. So to counteract with this natural source of reactive oxygen species, the steroidogenic tissues have large concentration of naturally available antioxidants such as vitamin C and other antioxidant enzymes in you can say our steroidogenic tissues. So thereby we can protect ourselves. And on the right flank, you can see, especially in the mitochondria, at complex 1 and complex 3, there is electron leakage. And that electron leakage is finally responsible for production of H2O2. There are further sources of endogenous origin. You will see that reactive oxygen species is also produced in immune cells, especially NOx pathway. If we talk about neutrophils, eosinophils, mononuclear phagocytic cells, they produce ROS. And especially if we talk about neutrophils or mononuclear cells, the bactericidal activity of the intracellularly ingested bacteria depends on the production of ROS. In this slide, simply it is, you can say, summarizing earlier 2-3 slides, non-biological pathway and biological pathway. They are producing superoxide radical. Now, these superoxide radicals, they are responsible for this production of H2O2 by using SOD, superoxide dismutase enzymes, and this superoxide radical is also responsible for conversion of nitric oxide to ONO radical at the same time that ONO radical is again converted to hydroxyl radical. So you will find a complicated, intricate system. So we can find production of H2O2 along with hydroxyl radical and other radical, and these radicals are responsible for cellular damage. But our system has catalase and glutathione peroxidase enzyme, and they are responsible for breaking down H2O2 to water molecule. In this slide, you will see how superoxide radical is converted to hydrogen peroxide. SOD is there, and if this hydrogen peroxide is there in presence of iron, you will find iron 2 or iron 3 hydroxyl radical is produced, and that is producing oxidative damage at protein, lipid, or DNA level. Similarly, this hydrogen peroxide is broken down to water and H2O plus O2 in presence of catalase, but there is another cycle through which H2O2 is also broken down that involves GSH peroxidase. We find GSH reductase, and H2O2 is broken down to H2O molecule. In the right bottom flank of this slide, you will see where we find the attack by hydroxyl radical if it is a benzene chain-like structure. In this, all radical sources are there. You will see they are attacking our nucleic acid, protein, lipid, carbohydrates, and our system, especially antioxidant enzyme and radical scavengers present in the living system. They try to just quench the radicals so they can save nucleic acid, proteins, and other biomolecules. Similarly, if we talk about at nucleic acid level, you will find repair mechanisms are also there. So they try to repair the lost bases at appropriate basis. So they try to minimize the alterations done at the level of our what we call biomolecules. But everything cannot be repaired, and every radical cannot be quenched. So ultimately, it leads to damaging proportion. Finally, epigenetic machinery gets damaged, and that leads to maybe cell death or age-related disease emerge, or aging acceleration starts. We know that when we talk about aging, obviously, number of theories are there. For aging, one theory is free radical generation. Over the lifespan, we are continuously exposed to number of free radicals. So that is responsible for creating the overload of free radicals, and that free radical overload is responsible for aging-related diseases or aging acceleration. In our cells, we have one organelle that is known as peroxisome, and these peroxisomes are basically the major sources of free radical generation, because most of the oxidases which are responsible for production of the superoxide and other radicals, they are present. So in this slide, it is shown that how peroxisomes act as source of ROS or RNS. Now, in this, that was animation. I don't see any animation is active. Yes. Now I think this animation is not running currently on the screen. Here, simply, you will find different complexes, 1, 2, 3, 4, 5 are shown on this in mitochondrial chain, transport chain. And most often you will find the complex 1 and 3. When electron is passing through them, electron gets leaked, and this electron attaches with the oxygen molecule and finally produces superoxide radical. At the bottom flank, you will see H2O, O2 is there, and that is produced. If it is not minimized to basal level to H2O or O2, it can inflict damage at the level of complex 1 and complex 3. So hydroxyl radical generated in mitochondria directly attacks this complex 3, and once complex 3 gets, you can say, broken or gets attacked, if certain changes are brought about in its composition, obviously the normal oxygen, electron flow there through transport chain doesn't take place. And that leads to inhibition of, or you can say retardation of ATP synthesis and other metabolic pathways. Similarly, free radicals in mitochondria, they are also relating with the concern with the damage of mitochondrial DNA, we know. So if hydroxyl radical is present, it can also create damages at mitochondrial level. It can damage aconitase enzyme that is operational during Krebs cycle. So obviously, whenever these type of damages are taking place, they will produce pathological abnormalities. Now, if the free radicals are so harmful, why did nature accepted it to be produced in our living system? That is very important question. People always talk about that when it is deleterious to human body, nature would have warded it off, or it has minimized its level. But we know, why did nature keep it intact? We know there are certain beneficial attributes to free radicals. First is very important aspect, that is generation of ATP. If we talk about ATP generation, you have seen in the earlier slide that the electrons are flowing through complex 1 to complex 5, and ultimately ATP synthase complex, the cycle comes into picture and we find production of ATP. So if there is no free radical generation, just because leakage is there, your electrons are flowing. So we are finding generation of ATP at mitochondria. Similarly, many xenobiotics or foreign chemicals means any chemicals which is coming in our body, maybe pesticide, maybe food adulterants, or any other drugs. They are always xenobiotics. So these are detoxified in our system, especially liver is main prone for to detoxification. So what happens? Whenever detoxification process begins, free radicals are generated and they are responsible for detoxification of xenobiotics. Thirdly, you will find apoptosis is a natural phenomenon, or old cells die and new cells are being produced. So apoptosis is also performed with the help of free radicals. Killing of microorganisms and even cancer cells by macrophages and cytotoxic lymphocytes are also performed, because in our earlier slides, we have seen that how neutrophils or other immune system cells, they are responsible for production of free radicals, and these free radicals are ultimately responsible for killing microorganisms. Similar process is also adopted by cytotoxic lymphocytes for killing cancerous cells. Then oxygenases are there in the system. We know we produce, especially the students of biological sciences, they must be knowing that prostaglandins are produced. Prostaglandins and leukotrienes, they are produced in very minute amount with the help of cyclooxygenases or lipooxygenases. They behave like hormones, and their presence is mandatory for normal physiological activity. So these COX and LOX pathways are also running in presence of free radicals. But a certain level of free radical is required. If it is excess, obviously they would be detrimental. Now, this is again an extended slide of the earlier slide. You will find the presence of low concentration of free radical is important for normal cellular redox status, immune function, and intracellular signaling. So in this slide, immune system has been talked about. Neutrophils and macrophages use ROS to destroy engulfed microorganisms. And how this happens, you will see that superoxide is generated inside those cells, and ultimately the superoxide in presence of SOD converted to H2O2, and this H2O2 undergoes reaction in presence of myeloperoxidase that produces HOCl, hypochlorous acid. You must be knowing, you must have studied at 10+2 level, definitely how HOCl or hypochlorous acid is acting as a very strong oxidizing agent. So because of this HOCl activity, most of the engulfed microorganisms are killed inside our cells, in cells of immune system, you can say. Now, another aspect is damaging aspect, tissue damage by free radicals. We know if they are produced inside the cell, they might lead to or double-stranded, single-stranded DNA breaks. They can, and it might lead to heritable mutations. Sometimes we can find induction of cancer, even oxidation of polyunsaturated fatty acids in lipids, especially in the membranes, that is quite detrimental. Lipid peroxides, if they are generated continuously in the system, at larger level, they might be responsible for atherogenesis or atherosclerosis, we know. Similarly, we know the oxidation of amino acids, especially if free radicals are higher in quantity, higher in load, they will directly create oxidation of proteins. And once the proteins are oxidized, some of the proteins, they are not recognized by our system, and our body system treats them as foreign proteins. So that is the factor leading to autoimmune disorders. If we talk about rheumatoid arthritis or any other type of things, you will find our own system acts like a foreign system. So we start generating antibodies, and in that process, we are getting harmed. So these are few examples of damage inflicted by free radicals. Now, in this slide, we can see the ROS. They generally attack fatty acids, DNA, protein, or cholesterol molecules in our living system. And in the picture, you will see a round object is hitting a membrane structure. So they might contain fatty acid, DNA, or cholesterol, and this oxygen-free radical attack is responsible for crumbling the structure of these biomolecules. Now, this initiates a rapid destruction chain reaction if the radical persists for a longer time. Now, it subsequently results in injury to tissues and formation of more free radicals because of the chain reaction. And ultimately, we are finding the damage to cell membrane, lipid, and proteins. Similarly, we can observe precancerous changes in DNA. We can find oxidation of blood cholesterol that leads to heart disease. So all these changes or altered functions as a result of free radical attack, they ultimately guide us towards cancerous growth or maybe heart disease or macular degeneration or other diseases, or we can find acceleration of aging and age-related complications. On the bottom flank of this picture, you will find how antioxidant vitamin A especially, acts like a wall and it inhibits the action of free radical. Means we can say the antioxidant or antioxidant vitamins, they act like free radical quenchers, and thereby they are responsible for saving the structural integrity of our biomolecules. In this slide, you will see number of ROS and number of biomolecules, especially at a structural level, what we have discussed in earlier slide. So I think if you are at your computer screens, it might not be very visible to you. Again, similar, these are different pathways showing how free radicals damage DNA or other molecules. These are different, you can say, pathways. I'm skipping. Now, if we talk about the role of free radicals in gene expression, I think this slide is visible to you. You will find H2O2 is produced, free radical NADPH oxidase reaction is there. So H2O2 produced inside the cell, it goes inside, it can attack phosphatases, it can attack JAK and STAT system, it can attack MAP kinases, it can attack NF-kappa B, and other ion channels or guanyl cyclase. So what will happen? Obviously, if it is continuously attacking, we are undergoing redox imbalance in the system. So our functional enzymes, they lose their activity or their malfunction is apparent in the cellular physiology. And at the same time, all these pathways, if it H2O2 goes to gene it might directly affect our gene expression by changing the genetic attributes. Now comes the antioxidants. What are antioxidants? You will see the antioxidants are substances that neutralize free radicals or their action. So in earlier slide, we have shown you that there was a wall-like, 2 slides back, there was wall-like structure of vitamin E, how it was preventing the damage. So in the same way, there are many more antioxidant molecules. Maybe we can talk about vitamin C, vitamin E, and other vitamins, plus maybe number of mineral salts and food items. They try to neutralize our free radicals. Now, humans have evolved a highly sophisticated and complex antioxidant defense system, you can say. So whenever there is a free radical load, our enzymatic machineries come into picture, just like in case of war. If there is war from one enemy country, the other country immediately retaliates by sending its own weapons to neutralize those war arsenals. So in the same way, if free radical load increases, our system just triggers our own protection system and it tries to neutralize at towards a basal level. Thus, antioxidants are capable of stabilizing or deactivating free radicals before they attack or during attack process, you can say. So that is why antioxidants are absolutely critical for maintaining optimal cellular and systemic health and well-being of the system. In this slide, you can see the natural antioxidants. Enzymatic antioxidants include SOD, you will find SOD, catalase, glutathione peroxidase, glutathione reductase. You will find different dehydrogenases. So they are part of primary or secondary enzyme system to just neutralize the free radicals. Similarly, non-enzymatic antioxidants present in the system, they include different minerals, maybe zinc and selenium. If you remember,
Sorry for the interruption, sir.
yes.
Sir, please expedite the lecture because we are having another lecture on time, and our invited speaker is here. So, if you
Oh,
can
hold on.
summarize.
I can. Okay. I'm so sorry.
No,
So
no problem, sir.
So this slide simply shows how free radicals are responsible for neutralizing action. Now, just for 2 minutes, I will talk about natural products, and I would like to finish my lecture. Now, why natural products are? Because they have ample diversity and they have evolved against evolutionary challenges. So we have number of molecules in nature which can provide protection to us. So still, if we talk about our Indian system, you will find 70% population still believes on our system. So if you look at the herbal world market, it is continuously gaining momentum. And by 2026, it would be a $212 billion market. These are examples of some plant products. This graph simply shows the natural product, especially if you see the fruits are preferred, leaves are preferred. I mean, overground structure of plants are responsible for producing most of the chemicals. So they are preferential, but at the same time, roots, rhizomes, and seeds are also used for production of natural phytochemicals. So you will find natural phytochemicals found maximum use during the COVID. A lot of Ayush and Ayurvedic formulations, they showed the growth of Indian herbal market, especially in 2021. So when we are talking about free radical load, we are just getting, you see the non-communicable diseases on right on account of the free radical overload. And in this, you will find cancer is growing rapidly, ischemic heart disease growing rapidly, but bacterial diseases are coming down. So these are the data. Some of the research work related with this thing we have also performed in our laboratory. We have shown the antioxidant activity of different extracts as well as pure phytochemical moieties. They have utilized the reducing power or free radical scavenging activity or metal chelating activities. I'm not going in the detail because time is short. Similarly, free radicals are also involved in you can say liver toxicity. So number of hepatotoxic ingredients, hepatoprotective ingredients are there in our system, in our natural products. We try to utilize them to protect our liver system. So these are different works we have performed in how it is responsible for lowering down as GOT, GPT, LP level in our toxicity. So liver function is brought to the normal. These are similarly cancer. We have also looked to the cancer aspects. How most of people know how cancer is produced, precancerous stage to cancerous stage. So we have seen the natural products have shown their viability in fighting against natural cancer. Even if you talk about vincristine, vinblastine, Taxol, everything, they are still natural product. So I think I've very rapidly moved our slides. So in the last, I'm coming to this slide. This is simply showing that natural products acting as antioxidant, hepatoprotect, and anti-cancer agents have enormous potential to act redox regulator. Means they are responsible for maintaining our homeostasis or redox system in homeostasis. So sustainable environment is key to sustainable health. Thank you all for patiently listening my lecture. Though I'm sorry I could not give you the detailed account because of the shortage of time. Anyway, thank you so much. Thank you.
Thank you very much, sir, for your detailed and very interesting topic. You have told because many aspects are there. Because of the time of shortage of time, we cannot remove that, but
No,
many
I
points are there.
understand.
Thank you very much. Okay,
you.
at the end of the session, we can ask for any questions if anyone have any query. So let me introduce Professor Dr. S.P. Ganchodhary. He is a renowned figure in our renewable energy sector and especially in the world, not only in
Can I
India,
hear?
but also in world. He is known as one of the greatest person. So I will now ask our Dr. Nidhi Shukla to introduce Professor S.P. Ganchodhary and we can start the continue the session.
Good afternoon, sir. Good afternoon to our invited speaker. I want to give you a brief introduction about Dr. S.P. Chaudhary, sir. He is an electrical engineer from Jadavpur University who has worked for 27 years in the field of renewable energy. He also worked in academic and professional government bodies and energy development institutions. He has become renowned for his outstanding contribution to the growth of renewable energy in India. He is also a member of the advisory board of Bijli Clean Energy for All projects. Dr. S.P. Chaudhary previously worked on the planning board of the Tripura government in revising renewable energy strategies and was managing director of the West Bengal Green Energy Development Corporation, as well as special secretary under the government of the West Bengal. Outside of being an adjunct professor at Bengal Engineering and Science University, he is also the chairman of Ashton India Renewable Energy Collective and chairman of the NP Institute for Rural Technology in Kolkata. Director of the West Bengal Renewable Energy Development Agency, and he is also a member of Tripura Government Planning Board and Renewable Energy Consultant to the Lakshadweep Administration. He is also now Director of the West Bengal Green Energy Development Corporation and Development Consultant Private Limited. In promoting sustainable energy development through numerous published scholarly articles and for his leadership on the subject in international forums and conferences, Dr. Gon Chaudhary has been awarded a number of international and national awards, including the Ashton Award for Sustainable Energy in 2003 from the Ashton Award Trust, UK. Dr. Gon Chaudhary currently heads a number of research projects on renewable energy for the government of Tripura and West Bengal. Um, Sir, I want to invite you for your guest. Kindly
Okay.
address your lecture.
Yeah, am I audible?
Yes, sir, you are clearly audible, sir.
Okay. Okay. So, keep बोलो ব্যাস আর কিছু নেই, এতেই বোর্ডে দেখতে পাচ্ছেন। Okay, thank you very much. Um, Thank you. At the outset, I thank the organizer for giving me opportunity to speak here in this technological advancement on renewable energy, the webinar. I will be very brief because little bit I'm late. I have to attend another meeting. But anyway, it's all right. I will try to manage my presentation. Not presentation, I'll be discussing only, and I'll say something about the renewable energy program in the country and in the global context. So the renewable energy, if you look back to renewable energy program in the country, it started really with the oil crisis in 70s. But before that, if you look, there has been a lot of energy transition from the very beginning. If you look back 400 years ago, energy, as you know, energy is required for any activities. For doing any activities, energy is required. Even when we sleep, we need energy to keep our lung and heart functioning. So from from the old ages, we are using muscle power. We used muscle power for a long time, and animal power. Then we found muscle power, animal power is highly unproductive. We switched over to biomass. Then biomass to coal. Coal was discovered, and in 1669, and in 18th century, coal was used heavily. With the discovery of steam engine and the industrial revolution, the coal became really prime energy source at that time. But coal, as it is also polluting in nature, and by the same time almost, we discovered oil. You know the story of oil. Oil was first struck in Azerbaijan, Baku. The present capital of Azerbaijan. It was part of Russia earlier. In Azerbaijan, I've seen that how Caspian Sea, the people are getting oil there, and then oil spread it over the whole world, as you know, and its value we know today. So there was another transition from coal to oil. So first transition from human muscle power, then animal energy to biomass to coal to then oil, and oil became a major prime energy source. After that, the Russian came up with the idea of the nuclear power plant. They set up the nuclear power plant in 1954, the first 5 megawatt nuclear power plant, and to the whole world that yes, it is a solution of energy crisis, and we can continue with this nuclear power solution. Energy is a problem with the nuclear power. But again, nuclear power continued for about 20 years, from 1955 to 1970 or 80, up to 80. But with the nuclear power accident in Chernobyl and also the Fukushima accident, the nuclear power, there was a big question in nuclear power, and gradually you have noticed nuclear power is gradually phasing down really worldwide. In India also the scenario is almost same. An ambitious plan was there for nuclear power, but now still it is only 3,000 megawatt or 4,000 megawatt level out of 400,000 megawatt total installed capacity. But in 80s, what we have noticed worldwide, pollution from the power from the fossil fuel based power plant actually drove us to look for alternative energy sources, which are really infinite in nature, and also clean energy sources, which are really environmentally benign. If you look back in India in 80s, we started under Ministry of Science and Technology. At that time, there was in India in the sector of renewable energy, particularly in solar energy and wind energy, and little bit in the bioenergy sector. But later on, we really realized the potential of renewable energy. And in India, the Planning Commission, the then Planning Commission, they set up a task force at that time in 80s, 84, 85. And you know how renewable energy can play a major role in Indian total energy basket. That was discussed. I was a committee member at that time, though I was very young. But Planning Commission somehow, since I started the program in the country, you know, mid of 80s, the renewable energy, particularly the solar energy program. So they also invited me to be a part of the committee, and we made a plan for you know, the renewable energy program in the country. Renewable energy, as you know, in Indian context, we are not very rich in geothermal potential up to now. But we don't know the future. But in solar energy, wind energy, and bioenergy, these three energy sources, also small hydro potential in India is quite good. The renewable energy, basically these four energy sources, the solar energy, wind energy, bioenergy, and the small hydro power. These are the major sources where MNRE and other departments of the state government and other public sector undertaking they are working on. And these are the most main thrust of the government, where government is to work. Now, after 80, we that was a beginning. That was the beginning. Then in 90s we started demonstration program in the country, and we demonstrated a lot on solar photovoltaic. Small pumps were installed, irrigation pump, drinking water pump in 90s. You know, the program took off in a we installed a lot of solar wind power plant also in 90s. And in after 2000, actually, it took a different turn. You know, the environment concern and the climate change and global warming issue. Initially in India, we started the program keeping in view that at that time in 80s and 90s in India, almost out of 6 lakhs, 600,000 villages of India, only 40% were electrified. And balance 60%, we were concentrating that through renewable energy sources like solar, bioenergy, and the other energy sources, we will electrify. Sorry. But that is called remote village electrification program of the that was called at that time. But later on, you see how it's changed. Later on in India, all the villages were electrified, most of the villages, with the conventional electricity. In 2005, a major program was launched, and the global attention that renewable energy will be utilized for electrification of remote areas, that concept changed. Basically, at that time, a new concept came, renewable energy for emission reduction. That is a big, you know, change in the approach. In India also, you know, that from the year 2000 onwards, 2005 onwards, you see, we started thinking in a big way with renewable energy as a you know, really alternative for the thermal power plant or coal-based power plant, or as an alternative. So try to understand. Previously, it was really the village electrification, RV program, remote village electrification program, access to electricity. For that, renewable energy was very appropriate. But after 2005 in India and worldwide, you see the entire scenario was changed. And at that time, renewable energy for emission reduction and protection of the environment, that was thought over. So a program, a national solar mission in India was launched in 2010. Actually, we wrote the mission paper, I can remember also. At that time, the government took a decision that by the year 2022, the government would install about 20,000 megawatt of solar power in the country as a part of the climate action plan. So you see the change, earlier it was for village electrification. Next, it came for the climate action under the program of climate action plan, National Solar Mission. So we started the program in India. Worldwide also, the US, the Chinese, they started late, but they came up with a very, very large, ambitious program. And they also started installing a lot of, renewable energy plants and other things. Now, in 2015, the present government, they changed the target from 20,000 megawatt to 100,000 megawatt of the solar energy by the year 2022. Now, after that, the climate convention, the climate summit, as you know, the Glasgow summit, Egypt summit, then the recent Dubai summit, climate action plan. I have also participated along with the Indian delegation. The government of India, along with all other almost 202 nations, they gave commitment that they will reduce the emission level by 33% by the year 2030. And in order to reduce the emission level by 33% by the year 2030, India is to install 500,000 megawatt. You have probably noted 500,000 announced by Prime Minister, 500,000 megawatt of non-fossil, power by the year 2030. That will ensure 33% emission reduction of India. So accordingly, Government of India, that policy, this announcement was made by the Prime Minister in Glasgow Convention, and based on that, all the states and all the other public sector undertaking and all the institutions, they have been asked to initiate research program, development program, and field deployment program in that line. So we are now really going in that manner. So this is the general history of really renewable energy promotion in the country as well as globally under the climate program. All the countries, climate fund has been generated, and the final decision is phasing out, not phasing out really, net zero target by the year 2070. That is the final target fixed up in the climate convention by almost 202 nations of the world who are the signatory in the memorandum. Based on that, we have launched our program, and we are from the government side, we are all state or central, we are all proceeding in that manner. Now in India, a lot of programs are going on, particularly in wind sector. In addition to the land-based wind, we have started exploring offshore wind also. The tender has been floated already for offshore wind, and Indian wind potential is more than 300 gigawatt, and including, of course, offshore. And we hope to achieve the target of achieving the full potential by the year 2040 in India, the wind power potential. The solar potential of India is 700,000 megawatt, and we have achieved only 100,000 megawatt so far, 85,000 installed and 15,000 in the pipeline. So we are going to install that. These are all power sectors. The hydro potential of India is about 150,000 megawatt. We have not really achieved more than 30% of that. So big hydro project as well as small hydro projects are also coming up in India. and bioenergy program, bioenergy mission has been launched in India. Side by side, as you know, the pump program and the Shurya Ghar program has been recently launched by the government of India. The Shurya Ghar program of Prime Minister, 1 crore houses will be connected with the grid. They will be generating power and consuming their power. That is a rooftop system, which will be subsidized system, as well as the beneficiary will get loan also. So this is a major program has been launched by government of India, which I think next 5-6 years it will be really controlling the whole energy scenario of solar energy scenario of the country. And the pump program, PM Kusum program, you have heard about that PM Kusum program. You install irrigation pump, and when you don't need any irrigation water, at that time you can export power to the grid and you can earn money. Similarly, in this Shurya Ghar program also, you install the rooftop solar power plant. Whatever is your requirement, you take that power back, you can sell into the grid. So in one way you protect. In addition, we have targeted for 100,000 megawatt of land-based solar power plant. Lot of tenders have been floated. NTPC and other public sector undertaking, they have been asked to launch this program. So this is the overall Indian scenario. What should I say, for the target fixed up by the government of India. But side by side, as you should understand that we have also launched a major program on hydrogen. Green hydrogen program we have launched in India. The green hydrogen mission has been launched in India. So it is also a major program. And at the same time, the e-mobility program, that is also a major program under the Clean Energy Initiative, Clean Energy Drive. In India, already you have noticed moving into the streets and roads, reducing a lot of pollution. Let's going for a major, renewable energy, and India wants to become a leader in the renewable energy program in the whole world. And our ministry, MNRE, they are doing on that. But side by side, one more important issue I should mention, and then I should stop. That is the research activities. So, because you are one university, so a lot of research. So like Amity University, I know Amity University is also. I have supported one program of Amity University from DST committee. They are implementing that program. So a lot of research opportunities are there in this area, particularly in the solar photovoltaic system engineering and material development. A lot of perovskite solar cells are coming up. The government of India is again launching a mission on that to reduce the price further, reduce the price of the solar cell and the efficiency, improving the efficiency of the solar cell. Perovskite is coming up, and also the other material, other type of solar the material, solar cell material. A lot of research activities are going on. Then in the smart grid area, a lot of research activities are going on. We have supported a lot of programs of IIT, and I'm particularly involved in 3-4 committees. I'm chairing 2 committees of Government of India. So I know how much we have supported for the solar energy and other renewable energy program to IITs and other institutions, other universities, particularly in the hydrogen also. A big initiative has been taken up. The e-mobility, e-totos, e-rickshaws, and the smart grid everywhere. Lot of programs, even the AWG. Recently, we have supported a project of Jain University in Karnataka. Big project. As you know, atmospheric water generator. With solar power driven atmospheric water generator for remote areas. So we have launched and India has launched a major program on Prime Minister has announced one sun, one world, one grid. That program, a lot of research activities are going on. There will be finally one grid, regional grid, starting from say India to US, so that everybody will export power to the grid. And when India is having sunshine, US will be not having sunshine at that time. They will have night, and we will export power to them. And during our daytime, night time, US will be having sunny areas. At that time, they will export power to us, and we will import power from US. So that concept is called international grid. That program, I'm involved with that. In fact, after 2 days only, there will be a big webinar we are organizing and with ISA, International Solar Alliance, that is on this particular topic. And these are the areas, where huge, immense opportunities are there for doing research. And every year, Government of India on energy, water, and environment. They have a lot of fund, lot of collaborative efforts are also coming up from other countries. We are getting fund. Funding agencies are coming up for funding this type of project. So what I would request Amity University to look at the call of and other universities or other institution call given by DST in this particular area, renewable energy sector, so that in future, side by side, deployment in one way, as I have mentioned, by the ministry, by the line ministry, by the central power sector in utility, they are doing, and at the same time, the university, the academic institution, they can take up a lot of research work in the clean energy sector, whatever I have mentioned, and finally, our target is to keep a livable world and green world for the future generation. So since I have to leave, I thought I should share some of the views, some of the ideas I've got with you. Thank you very much for patient hearing. Thanks, Amity University. If you have any question, because I will be leaving, you can ask me in 1 or 2 minutes, or otherwise, thank you once again.
Thank you, sir. Thank you for your words and many informations we have gathered, and whatever is at present, whatever is happening in India and different schemes. So I think the participants will gain very good knowledge and what are the future aspects in this area. So I will ask the participants, if you have any query, you can ask, because sir has very less time. Or otherwise, we can send the questions or queries later on.
Yeah.
Very good afternoon, sir. This is Dr. Swapnil from MIT Gwalior. Just want to say this was a very nice lecture and very informative.
Thank
So,
you. Thank you.
Thank you so much, sir. Thank you for your joining the workshop and delivering a talk on a very relevant topic.
Thank you very much. Thank you.
Thank you so much. It's our what I can say. It's a good opportunity for us, for all the participants, as well as for the Department of Environmental Science.
Okay. Thank you.
As an expert lecturer.
Thank you very much.
I think Dr. Malik, you can collect the
Yes.
questions, and then you share with the sir, and then you can take the answers.
Yeah. That will be better.
Sir is busy. I think
Yeah.
we should not
Yeah.
engage him too long.
Okay. That
Thank
will
you
be
so much,
good.
sir. Yeah, thank you.
Thank you, sir. Thank you.
Thank you.
Really was
Thank
a
you.
very informative session. Thank
Thank
you, sir.
you. Thank you very much. Thank you.
Thank you.
Bye
Sir.
bye.
Okay, Dr. Shukla, we can conclude the session. Just I mentioned some points, key points from this lecture.
Okay, sir.
There were two invited and guest speakers in this session, and first was Dr. Ramay, who he has spoken many important points about the redox reactions, free radicals, non-biological pathway, biological pathway, and then oxidative damage, GSH peroxidase, and he has also talked about the projected global systems on that. And after that, we have listened to Professor S.P. Gonchodhary. He has given in-depth data and information regarding the present scenario of renewable energy status in India and what the planning commission is planning, what are the future conditions in especially the sectors like solar, wind, bio, and hydro. And it has been also mentioned that there was many conferences like Glasgow Summit and regarding the offshore and onshore. And also we have been targeting, like presently we are having 100,000 megawatt of solar energy, and we are targeting 700,000. And also there are many projects are coming on, especially Dr. Kanchudi has mentioned about atmospheric water generation, especially in remote areas. Then bioenergy mission, and we have a great opportunity in the hydro sector also. It has very less has been explored, and there are many things to do. And then there is also scope of hydrogen operated vehicle, green hydrogen, that is in the new schemes. Government of India is targeting, also new mission is there. Bioenergy is another new sector which is a vast area, and that can be achievable for different purposes. Different new projects can be done, new research work can be done, and as a result we can flourish very well in the renewable energy sector in upcoming days. So I thank on the invited speakers and our guest speaker Professor Ganchodhary for giving this valuable time, and I also hope the participants have gathered some knowledge. So I am concluding the session here. uh, okay, Professor Rai, this is, I think we should conclude.
Yes, sir,
um,
we should end the meeting.
Okay. I would request the IT to conclude.
Thank you, sir. Thank you
Thank
so
you,
much.
sir. Thank you.
IT, please
Sure.
close the session.
Thank you very much. Really a very well designed
Yes, sir.
session. Thank
Yes,
you.
sir. Yes, sir.
Thank you.
Okay, sir. Thank you. Thank you, sir.
Who is from the IT?
अरे नहीं कुछ नहीं मुझे भी तो कभी बनना नहीं ऐसे क्या चलाओ तो कैसे नहीं क्योंकि आई इंस्पायर फ्रॉम आपकी रिवर घुमा देगा नहीं नहीं इतना
Malik sir, tell him to switch off this session.
if you permit मैं